So today we're going to be exploring bivariate data. In this video, we're going to go over how to read and interpret computer outputs, including slope, y-intercept, standard deviation of the slope, and standard deviation of the residuals, as well as interpreting least squares regression lines, residuals, and residual plots. So let's go over an example problem and understand the process. So this problem is Sarah took a random sample of 10 countries to study fertility rates in babies per woman and life expectancy in years. She noticed a strong negative linear relationship between those variables in the sample data. Here's the computer output from a least squares regression analysis for using fertility rate to predict life expectancy. Now let's talk about the values in this table and what they mean. Starting on the left side of this chart, we have the constant and the explanatory variable. In this output, the explanatory variable is fertility. Then in the next column, we have the values representing the constant and the variable. This number represents the coefficient of the constant, or the y-intercept. In this situation, the y-intercept is 89.7. This is the value of the response variable when the explanatory variable is 0. So in context, the predicted life expectancy is 89.7 years if a woman has a fertility rate of 0. This value represents the coefficient of the explanatory variable, or the slope. This represents the change in the predicted y value for every 1 unit increase in the explanatory variable. In this problem, the slope would be negative 5.97. In context, this means that for every 1 unit increase in fertility, the predicted life expectancy decreases by 5.97 units. The number in the third column and the third row tells you the standard deviation of the slope. In this case, it would be 0.59. So with this problem, if we gathered repeated samples, we would expect the slope to vary by approximately 0.59 units. The bottom of the table tells you S, the standard deviation of the residuals, meaning that in this problem, the average amount that the observed values differ from the predicted values is 1.91 units. So, what did we get from the computer output? We found the information that the y-intercept is equal to 89.7, the slope is negative 5.97, the standard deviation of the slope is 0.59, and the standard deviation of the residuals is 1.91. So what do we do with all of this information? Well, once you've interpreted the computer output, you can use it to make a least squares regression line. Your least squares regression line allows you to use values of the explanatory variable to predict values of the response variable. The format of the least squares regression line is the predicted y value is equal to the slope times x plus the y-intercept. In this case, your slope is negative 5.97 and your y-intercept is 89.70. So your least squares regression line would be y hat is equal to negative 5.97x plus 89.7. Now let's move on to residuals. The difference between the actual observed values of y and the predicted values of y that you obtained from the least squares regression line are called residuals. Positive residuals means that the actual value was higher than the predicted value, so the least squares regression line underestimated the value. Negative residuals mean that the actual value was lower than the predicted value, so the least squares regression line overestimated the value. If a residual is equal to 0, then the observed value and the predicted values are equal, so the least squares regression line predicted the correct y value. We already know that the S value is the standard deviation of the residuals, which signifies the average amount that the observed values differ from the predicted values. In this problem, the average residual is 1.91. A residual plot shows the accuracy of the linear regression line by displaying the residuals on the vertical axis and the independent variable on the horizontal axis. When the points are randomly scattered on the plot, then a linear regression model is appropriate for the data. So for this data, a linear regression model is appropriate as you can see that there's no clear pattern on the residual plot. So what did we go over today? We went over how to read and interpret computer outputs, including slope, y-intercept, standard deviation of the slope, and standard deviation of the residuals, as well as least square regression lines, residuals, and residual plots.
Thanks for listening, and here's a practice problem for you to try it on your own.